collecting scents from flowers and plants.
Now, the idea here is that you heat at this end and you collect at the other. And so we should actually take a look and see if we can do a quick distillation with rose petals. First, we need to just put in a little bit of water. The water and steam will essentially control the temperature. What we don't want is for this to get too hot.
The trick with this kind of distillation is to use heat to release the scent molecules, but at the same time making sure that these delicate substances aren't destroyed in the process.
You actually use the steam to control the temperature, and the steam will carry those smells over. You can see the liquid coming up, condensing in the long tube. And there is already liquid coming over.
Through, yeah.
And that should be carrying with it some of the sort of rose water smell.
Yes, you can really smell it.
This picture shows a 14th century perfume distillery. Middle Eastern perfumes were known to have been sold as far away as India and China. The Islamic chemists also played a pivotal role in another more gruesome industry, weaponry. Historical records during the Crusades talk in terrified tones of how the Muslims would attack the Christians with burning missiles and grenades, striking fear into the hearts of the defenders. Many of these use a substance known as Greek fire. Islamic chemists improved on Greek fire by using and refining a naturally occurring resource, petroleum. They developed the idea of distilling petroleum, or naft, to create a lighter, extremely flammable oil, which they mixed with other volatile chemicals to make them burn furiously. And the result was clearly terrifying. What all these medieval Islamic texts on chemistry have in common is their great attention to detail, which is clearly based on careful experimentation. In fact, the whole idea of a laboratory where chemical and industrial processes can be tried out really takes hold at this time. The ingenuity of medieval Islamic chemists is impressive. But I wanted to know something deeper. What contribution did they make to our modern understanding of the principles behind chemistry? This is the centerpiece of modern chemistry, the periodic table. It lists all the known elements. Its key idea is to group substances with similar properties together. On the far right, for instance, are the inert gases. On the far left are the volatile metals. The periodic table is a triumph of classification, giving scientists a way of organizing their knowledge of the material world.
Classification is simply a way to think clearly. I mean, what you need when you have some ideas about how the world works is that gives you a kind of schema, and you chop the world up into categories. And that actually helps you to understand, to make sense of what's around you.
People have been trying to classify the material world since ancient times. The Greeks, for instance, thought there were just 4 worldly elements: air, earth, fire, and water. But this idea was a philosophical one and had little practical value. And that's what medieval Islamic chemists really changed. They used experimental observations to classify the stuff the world is made of. At the forefront of this was a medieval Islamic doctor and chemist called Ibn Zakaria al-Razi, who was born here in the city of Ray, just outside the Iranian capital Tehran, in 865 AD. Al-Razi's classification was very different from the Greek one. He argued, for instance, that minerals, roughly stuff we dig out of the ground, should be classified into 6 groups, depending on their observed chemical properties. The same guiding principle that lies behind the modern periodic table.
Now, what I've done is I've brought materials from his classification scheme. And we have here what he called the spirits. We have the metallic bodies. We have the stones. Then we have the attrements, the salts, and finally the boraxes.
Each of Al-Razi's groups had a profoundly different experimental behavior. For instance, spirits were flammable. The metals were shiny and malleable. Salts dissolved in water. Of course, these classifications are not the way we do it today. But the point is that for the first time, Al-Razi was grouping substances on the basis of experimental observations, not philosophical musings.
We've come over 1,000 years since the work of Al-Razi. What sort of debt does modern chemistry owe to him for his classification?
Well, I think with Razi we start to see the first classification which really leads on to further experiments, the first schema which allows people to start doing rational work. And so really he lies at the start of almost formal chemistry, which ultimately leads to our periodic table.
I believe that what we see in the work of the Islamic chemists and alchemists is the first tentative steps to a new science. Yes, by our standards, it contained a lot of magic and mumbo-jumbo, but it placed an emphasis on experimentation that was truly revolutionary. But bigger and better was to come, because Islamic mathematics and the experimental techniques of Jabir ibn Hayyan and Al-Razi were about to be welded together in a completely innovative way that would revolutionize their work and create the modern scientific age. Until the 9th or 10th centuries, ideas about science and how the natural world worked were dominated by the Greek philosopher Aristotle, and they were very different from ours today. He believed that mathematics was concerned only with an abstract world of perfect forms, of idealized shapes like circles, squares, and triangles. It had no power to explain what we observe in the world around us, a world characterized by irregular, wonky shapes and constant change.
Physics is a Greek word meaning the science of change. And for the classical Greek tradition, there was a strong sense in which the science of change was in contradiction with mathematics. Mathematics dealt with perfect knowledge, with the unchanging world of mathematical forms. And it seemed in principle extremely unlikely that processes of coming into being and passing away, of growth and of decay, of qualitative change, could be captured with the beauties of geometry and mathematics.
The story of how humanity shook off this idea and began to see that mathematics is actually an incredibly powerful way of describing the world around us is long and complicated. But for me, Islamic scientists played a crucial role, and I believe one man really led this movement to turn mathematics from a language of abstract thought into a truly practical science. He was, like me, from Iraq, and his name was Ibn al-Haytham.
What al-Haytham and his contemporaries argued for was the possibility, in a way, of a single science, which would be